1. So you're going to have 8 meters. So 1, 1, you're left with 6 meters. So the maximum width would be 6 with 6 meters squared. The next question is saying we've got a width of 3.2. So if you've got 3.2 here, you'd have 3.2 there. That's how I read it. If the width of the veg patch is 3.2, then you're going to have, that will take 6.4. You've got 8 meters in total, 8 meters times 6.4. That means the length could be 1.6. Find the area of those two. That would give you a 5.12 meter square meter veggie patch. And notice that it's better having a 1 by 6 than a 3.2 by 1.6. So I noticed that it's better to have it changes, right? So obviously depending. Let the width of the veggie patch be X meters. Okay. So now, this is where we get good fun. All right, this is the fun part. Oh yeah, can't wait. Oh, it's so exciting to be introducing this to you guys. I'm really excited. So we've got the width. Okay, we're going to say the width is X. So let's call that an unknown length. Now that length could take on any number. I mean, if it was 1, we'd know what it is. And X. So we've got the width of X. Okay. Find expressions for the length and area of the veggie patch in terms of X. Well, what's the length going to be? I mean, let's look at it before. Before, when we had a width of 1 meter, how do we have 6? And when we used 3.2 meters, how do we get to 1.6? So what's this width going to be? What's this length going to be? Well, if you think about the length, what that's going to be, I mean, you've got 8 meters to use, right? So your length is going to be, well, 8 meters minus whatever you use on these two. So it'll be minus X and minus X. Because if you have 1 meter widths, it'd be 8 minus 1, which is minus 2. If you use 3.2, it'd be 8 minus 3.2 minus 3.2, right? Now, obviously, we can simplify this to just write 8 minus 2x, which is like 2 lots of x. In this case, was 6.4. Before it was 2. So that's what our length is. So our length in terms of x, and note that's what it says here. Find expression for length and area of veggie patch in terms of x. First, we've got to find the length in terms of x. So I've written length is 8 minus 2.62x. So I can go 8 minus 2x. Now, this can take on any value. So really, it's, well, 8 meters is what you got, minus however much you've used off these 2x's. Can you guys just give me a bit of feedback, 0 to 5, how you understand that concept there for me? That'd be great. Anytime now. So that's our length, 8 meters minus 2 lots of whatever you've used on the other sides. Thank you. Slowly coming in. If you guys can make it a bit quicker, that'd be good for all of us. All right. So now we've got this concept, right? With, you know, we've labeled our side. What's the area going to be? Well, isn't area just like what we did before? We just went this by this, or, you know, 2 by 1 by 6 in the other one. So wouldn't it just be x multiplied by 8 minus 2x, which how we write that is area equals x 8 minus 2x. And that's it there. Now we could expand that, but I'm just going to leave it there. I wouldn't. So that's our area. Our area in terms of a variable. So if the width was 1, it'd be 1 times 8 minus 2 times 1. 2 times 1 would be 2. So it'd be 1 times 6. If the length was 3.2, it'd be 3.2 times 8 minus 2 lots of 3.2. 2 lots of 3.2 is 6.4. 8 minus 6.4 is 1.6. Don't forget. So it's just going to be 3.2 by 1.6. So it just really tells us what that length is. So it will tell you what the area is, right? Okay. Use your area expression from part C to find the area of the veggie patch if it's 1.5. So really, we know if it's 1.5, this would be 1.5, right? I'm just going to show you guys. And that means this would be, you'd be left with, you've used 3. So it'd be 8 meters minus 2 lots of this. 8 meters minus 2 lots of that. So that's going to be 5. So it's obviously 1.5 times whatever you're left over with, which would give you 7.5. But we didn't want to use that. We wanted to use the formula, but I'm just trying to show you how this relates to the formula. So all we do now to do that for part D, and I haven't done my annotation at all, I should be doing D, is sub in x equals 1.5. So area equals 1.5 multiplied by 8 minus 2 times 1.5, which is going to be 1.5, because that's what we did, right? We already did this, 8 minus 2 lots of 1.5 to get 5. So it's going to be 8 minus 3, and that gives us 5. 1.5 times 5 equals 7.5 squared meters. So there we go. By considering the length and width dimensions of the veg patch, what are the possible values that the width x can take? So if we think about it, what values can x be? Well, if you think just generally about it, I mean, it can't be any longer this way than what? I mean, if you went down, how far? You know, you made that really small and then came back. What would that be if that was your shape of your veggie patch? Well, that would be 4 meters. And technically it needs to be less than 4 meters, because if it was 4 meters, it would just go straight up and back down on itself. So we know the maximum is 4 meters. If you think about it another way, if you made it really, really small here, then all the way across would be pretty close to 8 meters. I mean, if you made that, you know, this would be like 0 basically, and that would be 8 meters along. But you could go 0.0001, right? And that would leave you that. So we know it needs to be greater than 0. The values of x, it needs to be greater than 0, but it can't be 0, because if it was 0, then it would just run on the fence and it wouldn't give you a veggie patch. And it also needs to be less than 4, because if it was 4 meters of width, it would just come out and it would go straight back. So it could be like 3.9, but then it would only be 10 centimeters across and then go back, and you'd have like, you know, a veggie patch that's 10 centimeters and 4 meters long. But I don't know what you'd be growing in there, beans or something, something pretty narrow that grows up. So I don't know how good that would be. So that's our limitations of x, okay? They're the only values they can take on. Use the suitable methods to predict the maximum possible area of the veggie patch and the dimensions that produce this area. So what we need to do now is we have a couple of ideas about basically what we can do. I mean, what do you guys think would be a good number to use? You know, if it's between 0 and 4, what would be a sensible thing to use? I mean, 0 would give you nothing.
2.
4 would give you nothing. So you'd use, what was that?
2.
I would use x equals 2, because it's like halfway between, you know? So let's try out that. So we can actually see if this works, okay? So we're going to plug it into the formula, and we'll just go with this. So we go area equals 1.5, 8 minus 2x. So we're going to sub in x equals 2. Area equals, oops, that shouldn't be that. That should be x. Area equals 2 bracket 8 minus 2 times 2. So that's going to be 4. That's going to be 4. 8 minus 4 is 4. So area equals 2 times 4 equals 8 meters squared. Now that looks pretty good. Now, if you think it's 2, I mean, technically, if we went like a little bit either side, say if we made x equal 1.9 and we made x equal 2.1, we'll see if that's less. So if we make x equal 1.9, so it's going to be 1.9, so the area will equal 1.9, 8 minus 2 times 1.9. And we're going to do another area over here, equals 2.1, 8 minus 2 times 2.1. Okay, we'll just get out a calculator for this one, because let's be lazy. And it's decimals, then that's fine, because we're doing an application. So 1.9 in methods, when you typically do application and specialist maths, you're actually allowed to use a calculator in the exam as well, and in your SACs. So they've got one exam that's non-calculator, and they've got another one that is. And the one that is typically longer. So that gives us 7.98 meters, right? And if we go slightly to the other side, let's just change these numbers around. So we're going to go 2.1 multiplied by 8 minus 2 lots of 2.1. It also gives us 7.8. Interesting. It gives us the same number, meters squared. So to me, what we've done there is we've kind of tested either side of 2, and we can see that when we did 2, it gave us 8 meters squared. So that looks like it's going to be the highest. Well done. Any